What's a digital twin, and why will it change the way AEC projects are designed and constructed for the better? Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. In this episode, I'll be speaking with Michael Warren, Associate Vice President of Digital Practice Innovation at AECOM, about digital twins, how they're used within the transportation industry, and the future of this technology in the AEC industry. With that, let's jump into today's episode. All right, it's now time for our conversation of the week with Michael Warren. Michael, thank you so much for joining us and welcome to the show.
Thank you for having me.
All right, folks, we got another great one lined up here, so we'll just dive right into it. Michael, can you tell us a little bit more about yourself and what you do on a daily basis over at AECOM?
I am Associate Vice President and BIM Director for Transportation across the East, which is the East Coast and Latin America. That's my primary focus, but I also support projects around the globe from all of my years of industry experience. I'm actually an architect by training and profession, but because of my BIM knowledge and early adoption of BIM 25 plus years ago, AECOM wanted to make a move to introduce BIM 8 years ago into transportation, trying to get ahead of the digital transformation market. And that's how I found myself at AECOM. I have my own practice in Pittsburgh before I joined AECOM, but the opportunity was there. The family wanted to move. They wanted to get closer to the beach and have some different life experiences. And AECOM was looking to hire in Philadelphia. And here we are, 7 years later.
Beautiful. Well said, Michael. And I think as we both know, right, the horizontal or transportation market, maybe not the fastest or quickest adopter of BIM, like let's say compared to buildings, right?
Oh, I've adopted it pretty fast. We've made that transition in a major way, particularly with alternative delivery projects. Progressive design builds are very large right now. And they all have BIM requirements. So the translation and the transition from vertical to horizontal just kind of went hand in hand. You just have to have an imagination and get creative and understand how to translate. What I tell people all the time is a column, whether it's on a bridge or a building. So the way we model it is the same. Everybody just looks at those terms differently.
Well said again. And, speaking of creativity, Michael, let's talk digital twins. What are some of the common misconceptions you encountered about the technology? And actually, let's start a little bit simpler. Like, what is a digital twin and how do you guys use them?
A digital twin is actually all of the data virtually that can be associated with a facility. That goes into asset management. Okay. And the problem that I found in the industry is people use the term digital twin as 3D model. The 3D model is just the container of the information because it's object oriented. So infinite amount of data can be put on the objects that live inside of that virtual environment. And that's what it is. It's a virtual environment that's a replication of the real thing. But the difference is everybody's not going through all the steps. If you look at like ISO 19650, which is the international standard for BIM, it defines all those various aspects of what should be contained in a model. And what I found is people aren't going to that level for the use of information and the purposing of data.
Makes sense. And I guess, Michael, so can you elaborate more on how digital twins are used in the context of transportation infrastructure? Like, what are the primary objectives or functionalities of the digital twin, and what is its purpose?
Ultimately, the goal is to get accuracy in things like bridge structures or highway grading or other things. But then it goes beyond that. It's starting to be used for sequencing for public outreach so people can visualize and understand what the repercussions are, where the route alternatives are, how long the road's going to be closed down, how long it's going to take to construct something. But then it goes beyond that. And this is what we're starting to see, where it's being used for pay quantification. So the models are being used against schedule, against just-in-time deliveries on site, where they're getting paid based off of the updates to the model.
So you're essentially reflecting construction progress, which, in the past or even in some projects today might be done through a spreadsheet or a ledger or something.
Spreadsheet or just a P6 schedule.
But now you're plugging that information into your digital twin, like you mentioned, right? Not just 3D model, all these different sources of information.
It's 3D model on steroids. It's critical path method associated with the objects in the model. So when a bridge is constructed, you're not just looking at necessarily a chunk that goes in, right? You can actually look and find out what's going on or planned on day-by-day basis and actually analyze that as it's being constructed. And bridges are the more complex structures, but the digital twin also gives information that can be used for machine grading and automation, survey control, other things in the field that assist and make construction more accurate. Super elevation, curvature, spirals, all the things in the industry that the layperson doesn't think about. The digital twin gives the engineer the ability to understand all of that and simulate it. We can actually simulate those elements at a speed ratio and then calculate, for example, when you see the sign, when you're making a hard turn on a freeway, it says 35 miles an hour. Well, we can calculate that and test that and find out what is the maximum speed before a vehicle would lose control, or what is the camber or curvature of the road for a semi that will cause them to tip because of that cant on the road.
So part of the digital twin is also simulating, right, real life.
Absolutely. Absolutely. And in the building industry, simulation is used for things like daylighting or program analysis with adjacency or life safety. The life safety side ties over to the highway, but there's more to it.
Speaking of which, do you have any examples, Michael, that you could share, like from real life projects, about how you guys use digital twins, how they've been successful, and like debunking any myths or misunderstandings along the way?
I just completed a project in Michigan. It was a 4-mile long underground dewatering tunnel, very large diameter, very large inputs with the drainage system to dewater reconstruction of I-75 in a portion of that highway in Michigan. And we simulated and modeled everything through design for clash, clearances, tolerances, other things, but also went a little bit further that we started to monitor throughout the life cycle as things were being constructed. It was a progressive design build, alternative delivery, but we were able to get feedback from the field and incorporate that into the model to advise the designers where there may be downstream conflicts that they had to take into consideration because of what happened in the field. The final deliverable was one of the first 3D as-builts based on as-built conditions from survey and LiDAR in the DOT industry. So I led that project. I'm very proud of it. Tens of thousands of files, a lot of maintenance, a lot of management, but it was a lot of fun to work on. And it was really cool to show MDOT the final result, which was class-free, delivered on time, on budget. Everything just worked out because of creating a digital twin through the life cycle of what was happening was incredibly valuable.
Could you speak? So, Michael, without a digital twin, like what does that as-built look like? Is it still 3D? Is it 2D? Without it, what does it look like?
Most as-builts are still being expected to be on paper.
Is it?
Right? Or digital paper, a PDF. And we know, and you should know as well as I do, that as-builts aren't really as-builts.
No, they are not.
They're as intended, right? And in the civil world, you can be off feet. The beauty of the digital twin and surveying in the field is you capture when it's constructed and modeling to it gives an accurate geospatial model, which I think is very valuable downstream. So now when you're doing surveying or SUE studies to ground penetrate with radar where things are, you can project that back to the surface and get a more accurate reading of where those elements actually exist instead of guessing.
So maybe like a utility, maybe some reinforcing perhaps, just depending on the specific need.
Utility, reinforcing. Reinforcing is big for degradation, spalling, cracking, but knowing where those elements are at, coordinating reinforcing like with abutments and scuppers and rainwater conductors coming off of bridges is huge. You know, you're talking 6 to 12 inch diameter pipe in most instances where that wasn't taken into account when the rebar was designed in place.
Mm-hmm.
And there's always a conflict, right? And something happens and then the water just discharges to wherever. And then you get flooding on the road and washouts and all kinds of other problems. The beauty of the digital twin on the transportation side is if you're doing it correctly and you're mindful about it, it brings all of that in the context and coordinates it all.
So then, Michael, so we talked about, right? So the digital twin, class detection, relaying info from the field back to the designers to make adjustments throughout construction. So like, how do you guys relay the info to the field? Is it 2D drawings? Are they building off 3D models? How does that work?
Both. The models now are starting to be used as reference documents. Some states have moved towards model as legal document where they want the model and the model is what is used to construct from. So there's a lot of sequencing that comes into play for the contractor or the contractors to take into account on work progress day to day that gets executed from the model. So instead of having static drawings that are two-dimensional where you do planimetric projections for sections and elevations and other things, or, you know, there's a lot of different aspects with highway. Ports and marine, same thing. Aviation, same concept. You're talking very large-scale projects where you're projecting. And a lot of error can happen from projections because you're not understanding the relationships of what's there. For airports, for example, we still get drawings that do not show elevations of pipe or the geospatial locations of pipe relative to walls or structural columns or other things. The contractor has to figure that out, do the interferences and class detection themselves. But with 3D technology, they have the ability to visualize it, bring that information into their fabrication software, which makes construction easier. It goes faster. They're designing the tolerance. They're designing the clearance. And it's easier for them to install because they can understand and visualize what is actually going on.
Sounds like more interconnectedness between design, fab, and construction.
Absolutely. I mean, that's what a digital twin should be. But when it's all said and done, if you're staying on top of that model and you're getting information back from the field, it's excellent for facilities or asset management. And that's the ultimate purpose behind a digital twin.
So, Michael, let's say you're like a design professional or somebody that's new to the field, haven't really worked with digital twins before. What are some of the challenges and obstacles that you're going to face if you're trying to implement or be a part of a team that's implementing a digital twin? And then how would you address them?
The knowledge of the industry, that's a problem. Because in school, the training is on the theoretical or pedagogical aspects of learning the industry. They don't teach firsthand the industry. Even though they're industry practitioners that are teaching, they say, well, you'll learn that when you start working for a company or a firm, right? So then you get put on very mundane tasks, picking up red lines and other things. That's not the same as actually doing it. When you're modeling it, you have to have an understanding. And the beauty behind the modeling is we need to start teaching this at the post-secondary level. We need to get people familiar with the software and the environment, because I can tell you, I've spoken about this a lot at trade conferences. The generational gaps between how we used to do things and the understanding of technology is vast. Millennials grew up with this and other digital toys in their hand. And everything to them was gamified. Whereas the boomers were used to drafting and everything on paper, figure it out, the contractor will work it out. I'm just showing design intent. So you have a generational gap. But the generational gap is you have the boomers who understand how to get it done and understand the constructability side of it and the pragmatic side of what has to be done through engineering or architecture. Then you have the juniors who are good at software, but don't know the pragmatic aspects of what it is that they're designing. The tectonics, the way that parts go together, and how you show that information in a document to make sure that it can be built.
So, and Michael, you started to touch on this a little bit, but are there any specific technological advancements or innovations that have enhanced the capabilities or usability of digital twins in recent years?
Generative design is huge, and it applies to all industries. And that goes beyond just the use of AI or machine learning, but generative design based on rule sets. And if you have those engineering and architectural principles as an understanding, those rule sets are very simple to program. And you can get many more iterations of a design faster, and then hone in on the ones that actually work for what the contract requires, which is number one. And then two, the understanding of the deliverable. What do I have to do to convey this so that it can be built efficiently, easily, on time, on budget, and my design intent is being followed?
Do you have any examples of how generative design is used in the industry today?
It's used in a lot of ways, mostly like on the highway side with retaining walls, noise walls, because you're looking at grade. Generative design can be used for the subsurface utility engineering aspects to avoid clashes, route piping and other things in very efficient ways that are stratified based on geography. So in the north, we have to have water and other things at a certain grade level because of frost depth, where in the southwest, you don't have those concerns. right? And it's an understanding of those two concepts. The other thing, we're working on a project right now that I'm the lead architect on, that's in Tornado Alley. And we were able to simulate building designs for facades and roofs in software to generate the best design concepts for the client that weren't just aesthetically pleasing, but functional and protected the property and the occupants in those, hazardous, threatening situations.
Which is awesome because, and I can even speak to this a little bit, but without those generative design tools, right, you're iterating through, one facade one at a time, one roofing system one at a time. And it sounds like it would be pretty tedious and time consuming to do so.
It's tedious, time consuming. Again, you have aesthetics that you have to consider. The client has needs they want you to consider, like make our building fit the region where it's going. They have a brand, but they want it to fit the architecture of the surrounding area. So the area we're working in is rural and very wooded. And it's an actual manufacturing plant for packaging processing. And we're designing based on that criteria. We're designing based on using wood, the innovations of wood, but also bringing in the aesthetic qualities of looking at, for example, a piece of cardboard and the strength that comes out of the corrugations in the cardboard that allow it to do what it does. We're translating that into the building and the building design to strengthen and reinforce the fact that we have these high pressure winds and we have microbursts and we have tornadoes and other things that we have to deal with. It's great with the digital twin to simulate and emulate all that. And with computational fluid dynamics, we can study what's actually happening on or around the building and design appropriately to handle those conditions.
Brilliant. And Michael, how do you see the future of digital twins evolving within AEC, particularly in transportation, but really in any facet that you guys work in?
I see a lot of opportunity with digital twin. And I'm not sure if you're familiar with NERF technology, but I see NERFs becoming very huge in the future. LiDAR scans take a lot of time to get those 3D models. Someone walks around with a 360 camera. It's only capturing what the navigation path they go on. But with all the 2D imagery that can be stitched together to build a reality mesh out of a NERF expands the capabilities beyond imagination. And it also provides the ability to take large language models that can learn from those photographs and start to do asset management from artificial intelligence and machine learning, knowing what an object is when it recognizes it from those photographs and that reality mesh. That's going to be massive. So I envision 10, maybe 20 years down the road, you're going to start to see, especially infrastructure, very large data sets where you're going to see highways around cities fully designed, fully immersed in three-dimensional technology, bridges, viaducts, access roads, ramps, the highway itself, signage, guide rails, all of it used for asset management from the capabilities of a digital twin.
I think about also the repair and restoration side. That's more of my focus and what I do, but it is amazing what, digital twins, reality capture can provide to even that back end of the industry.
Well, the great thing is getting out of linear information models into digital twins enhances that capability that you're speaking of. Because a guide rail might change down the length of a highway. But in a linear asset model, it's just a line that's geospatially referenced from station point to station point. It doesn't break up or define the qualities or attributes of what that guide rail actually is from station to station. You can't get a good read on it. The install dates and times and maintenance that's required, things like bridges, maintenance on bridge inspections. You can tie those photographs and those field test documents to actual geospatial locations in a digital twin. So when you click on a crack in that reality mesh that I'm talking about or the 3D model, it brings up a ton of metadata. Photographs, inspection reports, measurements, all kinds of things. The capabilities that I see are off the chart. Now, the problem that I have is getting others to see things the way I see them.
And that's probably the hardest part of all this is, and I say it a lot, rolling out technology, enterprise, and getting people to understand what's possible.
Yeah. It's or feasible. A lot of times I hear we don't have systems that are robust enough, or we don't have the finances, or we don't have the staff. Well, there are people like us that are out there that are capable of doing these things. It's a matter of having that dialogue and the education and the understanding. And one of the things that we do at AECOM is work with our clients to understand digital transformation. So that's key. That's paramount to what we do. So when I'm writing execution plans, it's not just for the internal team. That execution plan or model management plan is also for the stakeholders, so they can view it and understand how we're using technology to benefit the ultimate outcome.
And think about, every time you say hand over a brand new project, right? It's amazing over the lifespan of that asset, how much O&M goes into it, how many times people are taking site visits and capturing data, and the fact that you can store all that in a digital twin, one place for all the information that would otherwise be spread across, I don't even want to think about how many different locations, is really amazing. But like you said, there's a lot of legwork that goes into it to make that possible.
That's where the industry needs to grow. There's a lot of silos and stratification in agencies. We saw it on the design side. There are silos. Different departments do things different ways with regard to infrastructure, but all of that data at the end of the day has the ability to be imported, exported, shared, combined into one readable database that can be brought up in a tool like Power BI, where you can customize what kind of information you want to see at what time.
Brilliant. So Michael, as we wrap up today, thank you again so much for joining us. What final piece of advice would you give to engineers who are kind of navigating this landscape? It's changing. There's all sorts of new technologies. Things are being done differently maybe than we're used to. What advice would you give them to, take the next step, be able to use some of the things we talked about and enhance their careers for the better of it?
Don't be afraid. Explore. Do not be scared. We all played video games at some point during the course of our lives, whether it was as kids or as parents of children, playing games with them, right? Explore. Understand the digital capabilities that are there. Have just a basic understanding that it's not changing the way we practice. It's transforming the way we practice to be more informed, to be better educated about what we do with engineering and architecture, to take advantage of opportunities that weren't really conceived because the perception was that's going to cost a lot of money. but we can design a lot of iterations with that, with generative design, and cost them out. And what we find is we can build beautiful artifacts and incredible things just through simulation and testing alone. And where we are right now with technology gives us the ability to do that. The one caution that I have is the software vendors can't keep up with the hardware vendors. The hardware is getting so robust and so intense. The capabilities are off the chart. NVIDIA is doing amazing things. But we got to get the vendors in line to make the tools that we use capable of harnessing all that power and all of that technological capability that we have in front of us.
Beautifully said. And Michael, if the audience wants to reach out to you, ask you more questions about today's interview or just catch up, what's the best way to reach you?
LinkedIn.
Well said.
Just type in Michael Warren, AECOM.
And for those of you who don't have a pen, we'll include that in the show notes so you'll be able to reach out to Michael directly with any questions. But Michael, thank you so much for joining us today. It's been a real pleasure.
Thank you. I had a good time. It was a great talk.
Absolutely. Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.